So here's a lesson about how do we solve radical equations? How do we solve equations that have square roots on it? Um, so let's start. Now here, the main idea is that we're going to use exponents to eliminate radicals or roots. So the opposite of a root is an exponent. So we always use the opposite to eliminate anything. So let's start with some examples here. Let's look here. Let's solve the following. You notice that here we want to solve for b. B is inside the square root. So in order for you to solve the square root, there's some steps. First, we need to make sure that the square root is isolated, which it is. There's no number in front, so that's good. So now that the square root is isolated, we're gonna use the opposite to cancel it out. So now you gotta remember that if you have a square root, there's always an imaginary 2 there. So to eliminate a square root, we use the opposite, which is an exponent. So to eliminate that square root, we gotta raise both sides to the exponent of 2, because this way the exponent is gonna cancel out with the root. And now we're gonna have b minus 4 is equal to 3 to the second, which is just 9. And then you solve in the division, you just add 4. So you add 4 to both sides, and now you have that b is equal to 13. And this is pretty much it. You take the square root. You have a square root, you take the exponent to eliminate, and then you deal with the insides. Now, let's look at example 2. It might not be that simple, because now notice that in example 2, the square root is not alone. We have this negative 10 in front, and this negative 10 is multiplied. So our first step is to make the square root alone, or to isolate it. So somehow I need to eliminate that negative 10. Well, like we said, this negative 10 was multiplied, so we do the opposite to cancel it out. So we divide by negative 10 to both sides. Now they eliminate. So now we have that square root of b minus 10 is equal to 6. Okay, so now this is what we have. We have the square root is equal to 6. And it just becomes the previous problem. You know that there's an imaginary 2 there. If you see no number in the square root, it's always a 2 there. So if we want to eliminate that, we gotta use the opposite. The opposite of the square root is the second exponent. So we raise the second exponent to both sides, because once we do that, square root is going to cancel out with the second exponent. So now we have that b minus 10 is equal to 6 to the second, which is just 36. And then you just solve. So plus 10. 46. It goes to 46. This is it. Nothing fancy here. We just eliminate the square root by taking the exponent. So let's look at example 3 again. Notice that the square root is not isolated. The square root is not alone. So you need to leave the square root alone. Notice that the 10, it's in front, it's multiplying, so you need to eliminate that. And the opposite of multiplication is division, so that's why we got to, so that's why we gotta divide by 10. So you divide by 10, 10 cancels out, and now you have the square root of 9x is equal to 60 divided by 10, so that's 6. So what do we have now? We have the square root. Always, there's a 2 there. If you don't see anything in that square, there's always an imaginary 2 there. So there it is. So you notice for you to eliminate, like we said before, you rate the second exponent. So that's a 2. So now that we have that, the square root, we're going to cancel out with the exponent. So what do we have now? We have that 9x is equal to 6 to the second, which is 36. We want to solve this, so we got to divide by 9. So you got this 9. So now this says that x is equal to 36 divided by 9, which is, what's that, 4? Okay. So x is equals to 4. Pretty straightforward. You want to eliminate the square root. You want to leave it alone, isolate it. So you got to eliminate the number in front of it. Then you take the exponent to eliminate the square root, and then you just solve algebraically. Let's do another example here. Now, what happens if you have an extra term there? What happens if there's no number in front, but now we're adding a number or subtracting a number? Still, the main idea remains the same. You want to isolate the square root. So how do you do that? You want to eliminate this negative 1. This negative 1 is not multiplying, but it's subtracting. So we got to do the opposite. The opposite of subtraction is addition. So you got to add 1 to both sides. So now you have that the square root of b plus 3 is equal to 8. So there you have it. This is what we have. And again, you want to eliminate the square root. If there's nothing there, it's an imaginary 2. For you to eliminate that square root, you got to take exponent to both sides. So we have that square root cancels out. So now we have that b plus 3 is equals to 8 to the second, which is 64. And then you solve, which is we subtract this 3. So b is equals to 61. So that's what we have here. Nothing fancy. Eliminate that's negative 1 by doing the opposite to both sides. We have that 8. Eliminate the square root with the exponent, and then you solve. So let's do one more example here. In example 5. Doesn't matter if you're adding in front or before the square root. It doesn't. You still gotta eliminate that 10. It's 10 plus. So we have two terms here. So I need to eliminate the term that does not have a square root on it. So this number is not multiplying but adding. So we gotta do the opposite. So you subtract 10. Cancel out. So now we have the square root of 10m minus 1 is equal to 3. You got 13, take away 10, we got 3. Again, if you see nothing there, that's the square. So you eliminate it. You gotta take the square root to both sides. Oops, to both sides. Now what do you have here? Square roots gonna cancel out. So now you have 10m minus 1 is equal to 3 to the second, which is just 9. So what do we do now here? You want to solve for m, so you need to eliminate this negative 1 first by adding. So now we have 10m is equal to 10. Solve for m, 10 is multiplying, so we divide. So after all this, we see that m is equal to 10 divided by 10, which is just 1. Same process, take the square to eliminate the square root. Now, before we leave, I want to look at example 6, which now we're dealing with two square roots. On the previous example, we were just dealing with one square root. So what do we do whenever we're dealing with two square roots? But the idea here is that the square roots needs to be on different sides. So I have a square root on the left and a square root on the right. So that's our step. If you have more than one square root, you got to put each square root on its own individual side, which is what we have here now. Because once we have that, notice that you want to eliminate that square root, so you need to take, again, if there's nothing there, there's an imaginary 2. If you want to eliminate the square root, you know that you need to take the exponent to both sides. Second exponent to both sides. But notice what happens here. Square with the square root, they cancel out. That's the same thing that happens on the right side, so they will cancel out. And now we will have x plus 3 is equals to 1 minus x. So it's the problem in theory, it becomes easier whenever you have square roots on different sides. When you have a square root equals to another square root, they will usually cancel out because you take the square root to both sides. So now we have this. We just solve. No? Put the x terms on its own side, so plus 10. So now we have 2x plus 3 equals to 1. You want to solve for x. So we gotta limit it at 3. So 2x equals to -2. Want to solve for x, multiplying by 2. So you need to divide by 2 there. So we know that x equals to -1. So that's how you solve square roots. Now, one thing that I forgot to mention is that in every single problem here, we need to make sure that that our answers are actually correct. Because notice, so let me rewrite the original problem here. So x plus 3 equals 1 minus x. So let's just see if my answer makes sense. You should do this in every single problem, but I'm just going to do it on the last one. So let's just plug in -1 to here. Let's see what happens. So we're going to have -1 plus 3 equals square root 1 minus -1. So now let's see, what do we have here? 3 minus 1, so that's the square root 2 equals 1 minus a minus, that becomes a plus. So I have 1 plus 1, so that's 2. Does the square root equal the square root of 2? So that's good. It's good to always check. This is to check. This is for you to check your answers. You should try to check your answers when it comes to square roots, because there's something called extraneous solutions, and we're going to see that on the next video. But you should always check your answers. If you have an answer, plug it in. It only takes a couple seconds just to make sure you're right. Now, here we have your entrance ticket. Try to solve the following two equations here.